Okay, so today we're going to look at the actual method we will be using in most questions for differentiating. Okay, so I call it differentiating by rule, and I'm just going to show you a few examples. Now it is much quicker than doing it by first principles, and you'll get the same outcome. Okay, so these are the rules I'm going to go by here. Okay, so if you've got ax to the power of n, okay, so that's what we've got down here. So we've got 7x to the power of 3 ax to the power of n. Then to get your derivative, your dy dx, you multiply the a by your n and minus 1 from n. Okay, so we're going by this rule here. Okay, so for the first two, we'll write it down bit by bit, okay, and go through it. So we've got 7x cubed and we want to find dy dx. Okay, so we're looking for the derivative. So you can see here axn. So you can say your 7's your a, x is x, and then n's your 3. Okay, so to get your derivative, you multiply your a by n and minus 1 from your power. So you're going to say 3 times 7 x, and then minus 1 from your power. So 7 times 3 is 21, 3 take away 1 is 2. So dy dx of 7x cubed is 21x squared. And that's it. That's your differentiation done. So you can see it is much quicker. Now you won't necessarily have to do it and write it out in as much detail as you get used to it, okay? But just to get the hang of it, please do. So here we've got 6x to the power of 4. So again, you want to multiply the 4 by the 6 minus 1 from your power. Okay, so dy dx equals, bring the 4 down, multiply it by the 6, and then your power minus 1, n minus 1. So dy dx equals 4 times 6 is 24, 4 take away 1 is 3. So the derivative of 6x to the power of 4 is 24x cubed. Okay, and that's differentiation. Okay, so if we have a little look here now at, you've got more than one term. So we've got 2x squared plus 5x. Okay, so seeing as what we're doing over here, you're going to say 2, bring it down to front, 2 times 2, and take away 1 from your power. So dy dx equals, so 2 times 2x and minus 1 from your power, plus, now see here when there's no power, remember everything's to the power of 1, okay? So what you're really doing there is 1 times 5x and 1 take away 1. Okay, so when there's no power written there, it is 1. So this equals, so 2 times 2 is 4. 2 minus 1 is 1. So you're left here with 4x to the power of 1. Plus power of 1 times 5, so 5 times 1 is 5. X, 1 minus 1 is 0. Now from your indices, anything to the power of 0 is always 1. So that's 5 times 1, which is just 5. So our derivative here, so dy dx equals 4x plus 5. Okay, and all I did was 2 times 2 is 4, left, then 2 minus 1, I'm just left with x to the power of 1. 1 times 5 is 5, and then the 1 minus 1 left 0, so the x goes away. Then on to the next one, so we've got again 3 times 6 is 18, 3 minus 1 is 2. 2 times 3, minus 3 is minus 6. 2 minus 1 is 1, so the power of 1. Now, when you're differentiating, if you ever have a constant, so any normal number, they just cancel out, they disappear. Okay, so that's just gone straight away. So there's my answer, that's my derivative. So dy dx equals 18 x squared minus 6x. Okay, so basically what you're doing is, so if I have another example here, 5x cubed plus 4x squared plus 5. You just go power multiplied by the number in front, your coefficient, and then minus 1 from your powers. So 5 times 3 is 15, 3 take away 1 is 2. 2 times 4 is 8, 2 take away 1 is 1. Constants disappear. So that is your dy dx. That is it, differentiated. So you can see this is a much quicker way of differentiating compared to first principles, and you get the exact same answer. Okay, so this is the method that we'll use for the majority of the time during calculus.